PyCon India and have a chance to attend this conference and see such wonderful programmers and developers out here and have a chance to travel as well. Anand said just briefly about me, but talking today I'm going to talk about two things. I'm going to give a shorter talk about the Python Software Foundation, which many of you are somewhat familiar with, and I'm going to say a few more words. And then later on I'm going to get into a technical aspect of a talk, which is a little bit of a left field thing, but something that's very interesting to me about voting systems and voting technology and a particular system for casting ballots that I developed and with input from other people that has a number of very interesting, to my mind, security features that are somewhat, well, they're surprising that they can exist. But I'll get into that. I'm going to go through a bit with the PSF initially. So just by way of background, I wear a number of hats, but one is that I'm one of the directors of the Python Software Foundation. There are 11 directors of the board of directors, and there's a membership which is elected as well. I'm also, as it happens, chair of the Trademarks Committee, so I enforce the intellectual property, the logo and the word mark for Python. I'm chair of the Outreach and Education Committee, which does a number of efforts to broaden involvement in Python, particularly in communities that, or groups that have not been as active. A lot of what we've done is funding efforts to get more women into open source and programming, but there's a variety of things we do there. And, well, as a segue to the later part, I also ran the last election for the Python Software Foundation and sort of administered the system, which our elections are sort of trivial, but it's a fun thing to play with, and I hope that that part of the talk is going to be interesting to people. But there's a little bit more I could say about my background that may interest people. I know Anand and some others are familiar with the writing that I've done for a number of years. I wrote for many years for IBM Developer Works, which I think continues to be just a wonderful technical resource in a variety of programming topics. And I had the great pleasure of writing a column called Charming Python, which I haven't really done in, I don't know, 5 years, maybe a little less for the latest column. So you can find all the old stuff, but it's horribly out of date, and it's about old Python versions, but it was a lot of fun to do. And I also did a book which is equally out of date about text processing in Python, which may someday be updated. What I do for a living now, and I think I'll just go into a little bit of a segue of this because this may be interesting to some people. I work with a scientific lab, and this isn't why I was invited here, but it is something very interesting called DSHAR Research, which does research in computational biochemistry, and in particular has built the world's fastest supercomputer for doing this problem called molecular dynamics, which is the study of things like protein folding, interaction of proteins with candidate drug molecules, and with ligands and lipids and various chemical systems, which the hope is going to be of fundamental scientific importance at some point in the future. And this has nothing to do with my personal background, and so it's this strange honor that I was able to do this for the last 4.5 years or something like that. It's a wonderful thing, and if people after the talk are interested in asking me about this, I would love to talk about it. But in particular, I can give a little bit of a plug that the offices are primarily in New York for this company, but we do have a Hyderabad office, and so we have local Indian staff as well, who are programmers, but also we have some, it's probably not so much this room, but we have some actual scientists and chemists who work here in India, as well as some in New York and elsewhere. And my computer's gone to sleep. So that's exciting. If anybody wants cards for the HR guy from the company and to talk about that, I'm not the one who's going to actually have me saying that. I'm also by background an academic, and I had a brief career teaching in colleges, not in this sort of thing at all, in political philosophy, and then I sort of had to segue over to this thing, But amongst the sort of weird diversity of things I published in, I've published in voting theory and voting technologies and trying to get fair elections in the United States, but many of the same issues apply in many places. So the main technical part is somewhat inspired by that. So let me say a little bit of background. And this blurb is basically what you can find on the Python website, buried somewhere or another. But the Python Software Foundation is a membership organization, and its purpose is to advance the use of the Python programming language. And I forget if it's on the next slide, but also nominally our mission is to protect the intellectual property of Python. It's of course under a free software license, which is a very permissive license. It's sort of a complex license history where it's been revised a bunch of times and relicensed, and there's a sort of legal thicket about that. But the general idea is that all the creations that are maintained by the foundation are under a very liberal BSD-ish Apache-type license. It's our own, but it's that sort of thing where, I mean, it certainly protects all the freedoms of free software that an organization like the Free Software Foundation is devoted to, but it has an even more permissive terms in terms of reusing the code. But nonetheless, there can be abuse of it, and people have to attribute it, and they have to do certain things. Some of this is a bit arcane in U.S. stuff, but we're in the U.S. what's called a 501c3, which is a charitable organization which can accept donations on a tax-free basis if you're a U.S. taxpayer. I assume under Indian statute there's some other statute number that means the same thing. But that's just a nice way to run an organization like this, and it's the way that most of the free software organizations like Apache Foundation, Free Software Foundation, or other similar things are organized. We're not so big as some of those, but we're decent sized. And you know, as this full room shows, Python is growing all the time, so it's better and better. Well, this is what I just said about advancing the use of Python, and I hope that we can succeed in doing that in a variety of ways. And I also mentioned that we're composed of a membership who is, I forgot what the number is now, but it's a couple hundred people worldwide. And members of the PSF are folks who have been nominated by existing members and who wish to take a more active role in furthering the goals of the foundation. And we have several members in this room, I think 4 or 5 or something, people who are probably in this room are PSF members. And most Python programmers, most people who are active in Python projects, and even core developers aren't necessarily members of the foundation. It's a somewhat separate role, and exactly what it means to be membership is something that's actually, particularly recently over the last few months, is sort of a topic of renewed debate, and what does that mean, and what degree of involvement do members wish to have, or do we expect them to have, and there's things that'll be refined over time and resolved and ironed out, but it's a nice organization, and it's nice that it is somewhat community-driven, that it's membership-driven. It's not like a private, fixed set of people that's, has a restrictive control of something. It has a democratic feel to it, which I really appreciate. And then the membership, in turn, elect a board of directors, which is now 11 members. It's changed in size a little bit, and I'm one of those 11 members, and it's also been a great privilege to serve in that role. This I stole from a presentation that another one of our directors, Marc-Andre Lemberg, gave at EuroPython a few months ago, and there's dates on the numbers, and they're probably changed slightly since then. But just to give you a vague size of the organization, well, the first thing to say is we get most of our money by running PyCon US, which is a wonderful and huge conference, and if any of you can afford a really pricey plane ticket to go halfway across the world, please come to Santa Clara next year. It'll fill up, so it will sell out, and not everyone who might want to go can even go probably. But it's much like this, but this year we're going to have 2,500 attendees, give or take a few, and we have lots of sponsors, and there's a wonderful diversity of material that's presented at all different levels. So it's great, and it is the thing that actually makes money for the PSF, which is nice as well. You can see that this is from last year's PyCon. We made, what is it, about our total revenues were about 1.4 million US dollars, which is about 75 million rupees. Someone else can do the conversion more accurately than me. Of course, that's total revenue, and most of that was, paying for the venue and the hotels and the catering and everything else. But we made, whatever it says there, 277,000. And you can see below, this is what we have in the bank account, which is somewhat smaller numbers, but it's enough that we can do a lot of things worldwide to promote Python. A lot of this is covered in the sort of summary, but I think it's interesting to talk about some of the concrete things we've done as the foundation. One, as I mentioned, is we protect the intellectual property of Python, which particularly interesting to me since I'm chair of that committee is protecting the trademark. We have a logo that's registered in the US, and there's weird intricacies of trademark law where you don't want things to be diluted and you don't want them to be misused, and you don't want either the name or the image to be used in a way that misrepresents the mission of the foundation. And that's sort of a low-level thing that it's amazingly amicable because the Python community worldwide is such a wonderful community. I mean, my job doing that, which is sort of interesting. I mean, I don't know if anyone in the room is lawyers or dealt much with lawyers, but typically when you get trademark issues, it's somebody claims someone has violated a trademark, and the lawyer for the allegedly aggrieved party sends a nasty letter with a cease and desist to the other person, threatening all sorts of lawsuits and damages and things if they don't stop doing that. And that's not what I do. What I do is people write to me in the committee, or they write to somebody else, but somehow I become aware of a particular use of the logo or the word or something that's related to ours. Oh, by the way, I should say along that line, if anybody wants the end, I have some really nice iron-on logos that a company made that we approved that I can give out to about 10 or 15 people. I only have a few of them with me. They're just the logo that's there at the top. But the wonderful thing about being on the committee for me is every time we have an issue, somebody writes to me or I write to them and I say, well, maybe we have a problem with this use of the logo and maybe we can make an adjustment to the design. And every single time I send what really is a cease and desist letter, I get a thank you letter back. And I don't get a lawyer letter back, which speaks to what a wonderful community we have, I think. We also do things, we fund things. We fund coding sprints. We fund a lot of conferences, including this one. We've donated some money to pay for some of the expenses for PyCon India, but if I try to say it, I'm going to get the list wrong, but there's PyCon conferences in the UK and in South Africa and Singapore and Australia and New Zealand and Brazil and Argentina and other places that I should be mentioning too. And we give grants of various amounts to various of these conferences, especially the ones that are just new or starting up or trying to get on their feet. And it's nice if we can provide a little seed funding to them so that they can put together a larger and more professional conference with the goal, and who knows what will go with this one, that you folks will actually start making money from organizing your conference as well, and we'll see how that goes. We also do things like fund, this is all fairly small scale, but we fund development projects sometimes. That there's some particular corner case of some aspect of the Python standard library or some very important third-party tool or something like that, which is really good and really useful, but there's something missing, there's something broken, there's something that could be better. And usually development is done by volunteers as a labor of love, and that's the way that open source communities work, and that's wonderful, but once in a while I want to give something a little bit of a kick and make it happen faster. For example, I'm going to mention a couple examples, but I don't want to, the things that I forgot to mention are also important. But like, for example, the email module really had a lot of rough edges in its porting to Python 3, and we funded a guy named R. David Murray for far less than he could have made as a regular consultant doing his other job. Need to avoid the feedback. But, spending a little money on helping him along got the email module into wonderful, wonderful shape, and in 3.3 certainly, it's just a brilliant tool that's well designed and well built, and I guess Nick is going to talk about it tomorrow. I'm looking at it, I don't know if that's true. Another thing that is sort of a blue sky project, and I find just enormously fascinating, and who knows if it'll ever be anything, is we threw a little money at Armin Rigo, who's one of the core developers of the PyPy project, which some of you may be familiar with, which is this completely mind-melting, insane project to re-implement Python in the Python language with all sorts of weird, clever optimizations and just-in-time compilers and conditional code paths. It's complicated, but it parses Python code and then it gets this optimized machine code out of it, and that's what you actually run with conditional paths, and it gets all the dynamic nature of Python in there, and it was this thing that was started, I'm not sure how many years ago, 8 years ago, something like that, as a crazy idea, and the first time they came out with it, it was, they said, we have this great thing, and it's 1,000 times slower than C Python, and it's great. And then a year later, they came back and said, well, it's still great, and it's 100 times slower. And then they came back and they said it's 10 times slower. And then it got to the same speed as C Python, and nowadays, you get, depending on the benchmarks you look at, it's 10 times, 100 times faster than C Python, at least for many types of code that you might run. And it's sort of this, in normal people can't put their brains around how it does any of that, but it does, and it's amazing. Armin Rigo has this idea of trying to implement software transactional memory in Python. I don't know how many people in the room have heard of STM or know what that's about, but it's this idea that it's an approach to concurrency. It's a way particularly of getting code to run on multiple cores, which all modern chips have many cores, and you want to efficiently utilize all the cores on a modern CPU to run your parts of your task in parallel. And there's approaches to that. But one common approach is threads, and threads have locking and race conditions, and they're sort of a mess, and you wind up writing a lot of extra code and losing all the speed that you hoped you'd gain. Software transactional memory is this almost this elaboration of this aspect of the Python philosophy where it's easier to, well, the saying goes back a long ways, but it's easier to get forgiveness than it is to ask permission. So it basically says everybody just write to whatever, every process, every subthread, write to whatever memory you want, and if anybody complains later about it, then roll it all back like it's a database transaction and start over from there. And if most of the time, most things don't step on the same memory, then it's a big win. This is something that's not a Python thing per se, but it's something that doesn't yet exist well in any mainstream languages, and who knows, we may have it in Python before other languages have it, which would be fabulous. I just think that's a really cool project, and it may fizzle out, and maybe 3 years from now it turns out that he's going to say it really isn't practical. We do a bunch of other things. We have a brochure, which I don't have because it's not printed yet, and we're redesigning the website for PyCon itself. We have some big hardware donated machines to benchmark different Python implementations that are at that URL that I mentioned there. We do the sprints I mentioned. We give out awards to people. Water of a variety of sorts. But the last thing in particular brings me to something that I'm very happy, well, two things that I'm very happy to be able to do today is the PSF is very happy to be giving its Community Service Award posthumously to Kenneth Gonzalez, and watch that. I'm very sad that I personally never had the opportunity to know him, but I know that many people in this room, had close connections with him, and the things he's done for the communities have been just absolutely wonderful, and it honors the PSF to be able to give it to him. Somewhat related to that, the board of directors of the PSF heard about this effort by the Indian Python Software Society to create this memorial award in Kenneth's name that they'll be, it's their project, it's not a PSF project, and they'll decide the rules for who they'll allocate the money to and how they'll do it up. But the PSF is very happy to be providing some seed funding to the project so that they can have something in the, the bank account for this award, and in the future I'm sure they'll announce winners and announce how they're going to be allocating the funds. But I made the Community Service Award for Kenneth, and I'd like to give it to his daughter, Amta, as a gesture here, if I could. Thank you, Amta. Oh, can we get a microphone for...
Good morning to everyone. I'm Amita Gonzalez, and on behalf of my family members here, I'd like to thank IPSS and PSF for recognizing my dad's talents and dedication to this group. I thank you so much, and I'm really honored here to be here on his behalf and collect this. And thank you so much. Thank you.
So just want to see. How much time did I spend talking about the first part? About 15, 20 minutes? So what I'm going to do next is, that's my story about the PSF. Now I want to do a bit of a technical talk. And as I mentioned, the talk is about this thing that's fascinating to me, about how you can conduct an election that has a number of security guarantees to it, that has verifiability to it, that has reliability, that has resistance against tampering. And, well, I'll go through the details of it. But in particular, the PSF used this system to conduct the last several elections that it did. 4, I think, something like that. Which is overkill. I mean, I am welcome to, we could do almost anything. It's 200 people voting, and it's voting to confirm members, and occasionally it's voting to make some small change to the bylaws. And there's very rarely any real dispute about the issues, and kind of no one actually cares that much about making the voting secure and all these things. And most, free software, open source type of organizations are very similar to us in that respect. But nonetheless, I'm a techie and I'm a hacker, and I can make it cool, and so I did. Well, I do have these disclaimers that I put on here that the talk doesn't really have anything to do with Python. I'm going to show you a little bit of Python code that is going to be trivial and simple, and any of you could have written in 10 minutes. And it doesn't really have anything to do with the PSF, because anyone else could use the same sort of election method. For that matter, most of what I talk about, you could do with pencils and paper. There's a couple parts that gets into, like, you're going to compute an SHA cryptographic hash. Okay, you're going to have trouble doing that with pencil and paper, but most of it, it's not even really code. But I'm going to show you some code anyway, because it's PyCon. Okay, well, I mentioned this, that we conduct elections, and I've explained what they're about. But one of the key things in this model of elections that we can rely on, and many organizations can rely on, especially sort of digital, electronic, distributed organizations, is that we know exactly who the eligible voters are, and we have an email address for them, or some specific means to contact them. And this is known in advance and centrally maintained. And this actually isn't true of, well, I'm going to say this on the next slide. These properties aren't true of governmental, national, sort of legislative elections. And there's some people, people I've worked with who are very quick to jump to, like, if they think this is cool, they want to, run the city election that way or something like that, which has problems. I mean, there may be ways that something like that makes sense, but that's not what I'm talking about. I'm not making that political advocacy. But here's the things that I would like to guarantee. I'd like to create an election system that has these properties. I'd like to allow every voter to be anonymous. No one should be able to determine how anyone else voted. But I make a certain small concession here. You'll see why when I go into the details of the system. There is an election administrator in the system. There's a trusted party who can breach anonymity, who, if they wanted to, could find out how a given person voted. And it's sort of a flaw, but it's a flaw of convenience, and it makes things work. You can kind of make that a little harder for the administrator to have that breach of anonymity, but it's sort of there in the simple system. And again, I say don't do that for the public election, because you can't trust anybody. I guess people probably know this and understand this, but it's probably worth repeating that, in fact, there's a system called the Australian ballot, which dates back to the 1870s or something. It's called the Australian ballot because it was first used in Australia, maybe a little earlier. But the idea is, and I think that you're probably all familiar with it, either from actual national elections or from just your club elections. But it's just the idea that you mark a ballot, a piece of paper, anonymously. You don't show it to anybody, and every ballot looks the same as every other ballot. And then you stick it in a box that has a lock on it, and you don't tell anybody how you did. And at the end of the day, some group of people who don't trust each other, but they're all looking over each other's shoulders, opens up the box and counts the ballots. And because they started out looking the same, there's nothing distinguishable about them, and the anonymity of the individual voters is maintained. And it's actually, it seems painfully obvious, and yet elections predate that system by 2,500 years, and wow, people think of that. So it's kind of a clever technology with, boxes and boxes and pencils and paper that has a lot of desirable properties. There's some properties it doesn't have, though, and that we can do with electronic systems. I would like an election to be collectively verifiable. I'd like every observer of the system to be able to repeat the tabulation of the election themselves. That's the pencil and paper and Australian ballots they're not bad for that. You can have, the opposing political parties looking over the shoulder of the people who are counting, and there's the kind of verifiability that's possible to have there. So you can get that, but you can get it even more broadly in electronic ways. But the extra property that's interesting to try to get is I'd like for every person who votes to be able to determine that their vote was counted in exactly the way that they intended it, and that nobody ripped up their ballot before it was counted, and nobody made marks over their ballot before it was counted, and it really is their vote, and they can check that that's the case, which there's really no way to do with the Australian ballot. The other property is I would like for the election to be secure against tampering. I would like to make it impossible, or at least implausible, nothing in security is maybe quite impossible, so that nobody taking any malicious action can alter the results of the election. But in particular, and this is what is the trickier part, and this is what sort of motivated me to think about these issues and to give this talk, is I don't want the person administering the election, the person in charge of the thing, the person giving out the ballots and counting them and receiving them, to be able to tamper with the election. In particular, the last round where the PSF conducted the election, that person was me, and again, none of the members gave a damn. They didn't care. But for me, it was interesting to think about. I want to set this up in such a way that if I wanted to fake this election, I couldn't do so. Or in particular, if I tried to do so, the eligible voters could prove that I did so and catch me on it and invalidate the election, which I find it's a fascinating property that can be obtained. There's some things we don't guarantee in the system that I'm going to get to in a moment. We don't make any effort to prevent vote buying or voter coercion. We assume that all the PSF members who are geographically dispersed around the world in any case are, free of undue influence. Nobody's going to threaten them, no one's going to bribe them, and they're going to, have the liberty to do that. And again, this is in contrast to this sort of traditional ballot box, Australian ballot that I talk about, where it really does provide this very interesting guarantee against voter purchasing or voter coercion. So, there's been throughout the world corrupt elections, and one way elections are corrupted is, the criminal gang comes to your house and demands that you're going to vote for the political boss that they want you to vote for, or you're going to be in trouble. And there's this coercion and there's this forced vote. When you have the physical ballot box in the Australian ballot, it prevents that from happening. The mobster can come to your house and threaten you and say, we insist you vote for our guy, but you go to the polling place, you stick the paper in the ballot box, it's private, the mobster's not there, you go home, you lie to the guy. You say, yes, I voted the way you wanted me to vote, I did that, don't beat me up, don't burn down my house. And there's absolute deniability there. There's no way that the person who's coercing or buying on the, on the other side of it can tell whether or not you did what they wanted you to do, which is a nice property, and we don't have that in what I'm about to describe. Well, this is actually, we don't technically need this, but in the PSF and most organizations, professional organizations, we know who the members are. There's no secret about the identity of the members, and we publish a list of PSF members, and anybody can look at that, and that's sort of a special case. So let me go through and tell you how this system works, and it's simpler than you might think. The idea is basically just we have a list of voters. For every voter, we give them a unique identifier, a ballot ID. And that's just a random number that is known to this one person, the election administrator. The numbers are eventually known to everybody, but the mapping, the association between that voter and that ballot ID is known only to this one trusted person who's, who needs to be somebody disinterested, who doesn't care about the outcome, who's not invested in it. They could be hired for that reason or whatever. And then after these ballots that are anonymized but associated with a ballot ID are collected at the end of the election, the complete set of ballots is released, and since it's electronic, they're released as an electronic archive, and everybody can look at them, and everybody can tabulate them themselves. And we'll go through some details, but everybody can verify their ballots and do some other things that are nice. So let's just sort of walk through it. Suppose that we are conducting an election, and we have these voters, and these are all PSF members, and they're not all of the PSF members, but I picked ones who are likely to be in the room or whom I'm talking about. And they have names, and they have email addresses. And then we just run a little Python script, which is literally this short, which we generate some random numbers. Of course, we run it in Python 3 because everybody should be moving to Python 3. It'll happen someday. And we read this list of members, and we you can read the code. I don't need to explain what it does. But we create a ballot ID for everybody, and we just create this association between these random IDs and the names of the people. And that's this thing that's going to always be maintained by only the election administrator. And no one else is ever going to see this slide that I've just displayed, the file with it in it, except for one person who's trusted not to reveal it to anybody, but they're going to do things with this file. In particular, one of the things they're going to do is the election administrator is going to run a script that's send the ballots out, send ballot IDs, I generated this file. This is for the talk, this ballot map with yesterday's, actually there's an inconsistent date in my slide. I generated a couple of them, but in any case, it's a file, and it looks just like this previous slide. And all the script does, and you can find the script at the URL that I gave in an earlier slide. That's gnosis.cx/psf, and it's really, I'm not going to show you the code for it. It uses the email module and the SMTP module, and Unicode is a bear, and it sort of wrestles with some try-except blocks to catch weird Unicode things that are going on in ways that are annoying and frustrating to me, but it's still a simple script, but it's not worth showing here. But here's a detail that's probably not obvious. I want to prevent myself, the election administrator, or whoever's doing it, from tampering with the election, from falsifying results. And there's going to be a couple steps here. They're pretty simple, but what the election administrator needs to do is they need to commit to not to the association of ballot IDs with voters, but to the specific set of ballot IDs that will be used in this election. And, it says that on the slide, but you can make that commitment by using a cryptographic hash. So this is a bash command, of course, and I don't know if it's worth explaining what it does, but I cut out the column that has the ballot IDs from the file, which is the first 5 characters. I sort those ballot IDs, and then I do a SHA hash on it, and I publish this hash number. I tell all the world that. This isn't something that everybody can know, but I think most people in the room probably understand. But one thing, a cryptographic hash takes some larger document, and it creates a short digest. It creates a short summary of the document in such a way that no one can computationally, plausibly have any other document that would have the same hash. So by publishing this hash, that's a specific list of ballot IDs that no one could substitute a different list of ballot IDs that would have the same hash. But here's a little security thing to watch for. You notice that when I do this, I pipe it through sort along the way, because if I hadn't piped it through sort, once people which is going to happen later, found what the actual ballot IDs are, they would know that they occurred in a specific order. They would know that QG996 was the first of the ballot IDs, and they may be able to reason that in the list, Anand is likely to be the first person listed because he's alphabetically first. And, should I talk to this instead? Test. You want to just get rid of this? Or turn it off? Or?
Is that better? I apologize for the audio issue. Are we happy now, AV? In any case, if we hadn't sorted the list of ballot IDs, it might be predictable at the end what the list of voters was likely to be, and therefore when you saw the ballot IDs, you might be able to make reasonable guesses at least about which ID was associated with which voter, and that would puncture anonymity in a way we don't want. So it's as simple as sorting before we do it, and then they're just going to be in alphabetical order, which is random in respect to the order of the voters. This commitment that we make, the election administrator makes is somewhat nuanced. What happens is, at the end of the whole election, we publish the actual list of ballot IDs that we've committed to by publishing its cryptographic hash. If the election administrator hadn't published this commitment, they could substitute ballot IDs at the end of the process and stick in fake ballots that had the votes that they want to cast. But we've committed to these, and in particular, we've told every eligible voter what their ballot ID is, so it's detectable that somebody's going to say, no, that ballot ID, I mean, no one person will be able to refute a ballot ID, but if the number of ballot IDs is right, then some voter will be able to say, my ballot ID is not included because there must have been a substitution. So it's not individual verifiability of the total, but it's collective verifiability. If every voter participates and vouches for their ballot being present in the eventual archive, then nothing can be falsified along the way. I hope that makes sense. I can go back and try to clarify it. So here's the process. I mean, I basically explained it already. The election administrator sends out a personalized ballot to each eligible voter that incorporates the voter ID, and that's done with a little script that I had earlier. During the voting period, in real life, not everybody's going to return their ballot. Not everybody's going to vote, but they all have the right to. So we're going to get some of the ballots back, and they're going to be stamped with a ballot ID within them. And the more people participate, the better, but not everybody participates. In the last several elections, we've done this by email. It doesn't have to be email. It could be, well, it could be pieces of paper, put in the actual physical mail to people's houses. It could be some other digital internet protocol. And in fact, later I'm going to talk about a web version of the same thing that does basically the same thing and even a little bit more. But there's some transport of the ballots to the eligible voters. And this transport doesn't affect the guarantees. That's sort of the point. Email's convenient, and we know email addresses, but essentially it's just there's a way to contact people. What I'm describing doesn't address is, well, what's in the silly icon that I made, is there's no message level or transport level security. I wish that I could convince all the PSF members to generate GPG public keys, and I would encrypt the ballots before I sent it to them. They would, use the election public keys before they got the thing back, and nobody could ever listen on the wire, and everything would be secret. And I can't convince anybody in the world to use PGP, so I'm frustrated by that, or any public key encryption. But in principle, you could for some organization. So you could add this transport level security in some other hypothetical system. After the ballots are all returned, or all ballots that will be returned are returned, the election administrator publishes this archive that has all the ballots that were returned and they each contain a valid ID within them, or the name of the file, or they're marked in some way that indicates this unique ID that goes with it. And then the list of all valid IDs that were ever generated is published at the same time, so that I've got valid AB123 and valid CD456, and these are the ones that I've actually published. But I also say, and by the way, this is all 220 or 2 million. It's a big election, whatever. This is all the valid IDs that were ever possible to be voted, and some subset of those were actually voted, and this is the eligible ones. This is the actual votes. This is probably worth mentioning. May not be anybody in the room, but when you talk to people who think about elections, who think about voting, they tend to have opinions about the way that elections are tabulated. And for example, different governments have different styles of tabulation of votes. There's ranked preference voting, and within that there's condensate voting and Bordeaux voting and instant runoff voting, or single transferable vote it's called sometimes. These are all words that some of you will have heard of and some won't. There's first past the post, which is used in whoever gets the most votes wins. There's single round runoff, where the top two go to the final election. And in various jurisdictions, whether these are government jurisdictions or just organizations, various techniques are used. And I'm neutral as to that. This system is just collect a bunch of ballots, do something with them, and the tabulation procedure that's used. I mean, I can have opinions on those things, but that's not what this method is about. Okay, so let's review the guarantees that I believe that I've made by conducting it this way. I think that I've guaranteed collective verification, or verifiability, I should really say, so that every actual voter, everybody who actually filled out their ballot and sent it back to the election administrator, can look at this published archive and make sure that there's a valid ID, that it is their valid ID that's in this archive, and the content of it is exactly the votes that they wanted to cast and not anything else. And so that person knows that their vote counted. But also you can do this other thing. Every person who is eligible to vote, but for whatever reason didn't return a ballot, they decided not to vote, or they didn't make it by the deadline, or whatever reason, they can also look both at the collection of valid IDs that was committed to at the beginning of the process and make sure theirs was in the committed to list, but then make sure that theirs was not included in the actual archive of published ballots, so that they're making sure that their non-vote is a non-vote. Moreover, every observer of the election, someone who's not an eligible voter but just is interested in the outcome, can make sure the same thing about the subset relationship between the actual published ballots and the committed ballot IDs. And likewise, every observer who could be a voter, but could be anybody else, can run the tabulation themselves, and they can go through all the ballots and make sure the counts are what the administrator claims they were. So this is, once you've done all these things, you know that the result of the election was not fake. It really was what it claimed to be. Which I think is some cool properties to have. And the last, whatever I said it was, 4 PSF elections were done just this way described. There were emails sent out to the eligible voters, and most of them, the staff, PSF administrator, collected them and did this tabulation. And I did it the last round, and I automated things, and I wrote some more scripts, and I mean, she actually, looked at the individual files and wrote down numbers, and I'm a programmer, so I'm lazy and I don't do that. But it's the same idea. But also after this last round of elections, everybody has a better way to do it, and some people don't like filling out text files and getting it over email, and they want a web interface because the web is sexy and it's instantaneous and it's online, and probably 3/4 of you work professionally as web developers, so you'll be sympathetic with that. So a colleague of mine named Massimo Di Piero volunteered to make a web-based system. And I worked with him a bunch to, I mean, he had an initial system that was just sort of an interface for voting, and I didn't feel initially that it had all the security and verifiability and tamper-proof and anonymity and so on guarantees that I thought was important to have in a voting system. And so we've had some back and forth, and he made lots of improvements, and I'm very happy with what he's done now. And of course, it's open source. It's I don't remember what license it is, but it's it's a good one. And you can download his code. And also, if you want to look at that URL, you can use the site that he's hosting right now to conduct your own election. And there's an administrative interface, and anybody can log on. You have to, I think I mentioned on the next page, but if you want to be an administrator, you do have to log on. You have to use OpenID as a login procedure, and so there's some sort of validation of the administrator. And enter the list of voters that you think are going to vote, or that are eligible to vote in the election, and the rest is automated, and the voters can vote using this web thing. So it's simple and it's nice. So the code that does this system of Massimo is called eVote, which is way too generic of a name. There's probably 50 or 100 or 1,000 things called eVote, and I should convince him to come up with some other clever name. But in any case, it's not very many lines of code, and it's sort of interesting to look at. He did it within this MVC framework called Web to Pi that he's the initial author of, or primary author of, or something. And you could do it in anything. It's not, I don't care what framework you use. And it's just a few lines, and I care about what the logic of the vote is, what the security is. And I've looked at that, and it's well done. I mean, the stuff that I showed you before is less than 50 lines probably that actually matter, and his is, I don't know, a couple hundred lines. I mean, but it's not a lot of code. Well, so as I say, you can go to the URL that I listed before, and you can create an election. I mean, if you feel like go play with it after this talk and do so, with your 8 friends and vote on something. And the administrator creates a ballot using this markup format that's basically documented on the site, and enters the email addresses of the voters. And as soon as, first you create the ballot, and then you kind of go through some other screens, and then you say, do it. Now we're actually conducting the election. And then voters are each sent, I mean, there's this email aspect to it, a unique link with a UUID inside it that is a link to where they cast their individual vote. And when an election is created, voters get a email that looks like this one. I mean, I've taken out some of the headers, but this is an actual, election that I created and participated in for myself. So it's this, test eVote thing with, and I guess the 21 in there is it's the 21st election conducted on the system or something, which I don't know. It's just, they're all just testing by Massimo and me. And then there's the UUID for my unique voter thing. And so I go to a web page and I check off some checkboxes and pick lists and all the stuff that I configured with the markup interface. Stay away. And at the end of it, I get a summary of my vote, and the summary looks something like this. And this is probably too small for most people to read, but I just wanted to show you a picture of it. This is my simple election, and you maybe can't read it, but the question being voted on whether the security guarantees are clear in this voting system. And there's a ballot ID, which in this case is ballot ID 21 and 0001, because I'm apparently the first voter who voted in this election, and it's the 21st election. But the point is that it's a unique ballot ID that's specific to this particular ballot by this particular voter who happens to be me in this particular election. And now, here's the interesting part, and it's teeny tiny, you can't read it, but what it says at the bottom is signature, and then it contains a bunch of hex digits that you can't read, but there are a bunch of hex digits. So they have the ballot IDs, and that's similar to the system I described before. And then it does this extra thing where the mapping between the UUID of the URL that was used to get to the vote and the stored vote is erased in the process. So there's a verification that the UUID is a valid one, but as soon as you get to the website with a valid UUID for that election, you're assigned a random or sequential or something ballot ID from the pool of available ballot IDs for that particular election. In the case I gave, I was number one because I was the only voter in that election. But if it was 200 or 1,000 or a million voters, once you get in with valid UUID, you get a ballot ID that is you're given the web interface, but the association of that UUID with your ballot ID is erased and not stored anywhere in the database. So you never save this ballot mapping. On the other hand, I don't want to count on this guarantee too much, because if you had someone malicious who was running the web server, they could, of course, store it. I mean, the code that you can get from GitHub doesn't store it, but you're going to a website. You have no idea what anybody's doing. You have no idea who's listening over the wire or when things are being done. You have no idea about it. So the extra security you get by erasing that association or by not storing it in the database is something, but it's not airtight. But it doesn't really matter either. I mean, because it's no worse than the system I described before. That's basically what I say in that paragraph. So I mentioned this. The interesting thing about this ballot that we saw before, the completed vote, is that it has a signature. And the signature is an RSA public key signed ballot. So what it is there's a published public key for this specific election. And that's, of course, generated when the election is configured. And you can look at the code. And I used for this a pure Python RSA module, which is wonderful. I mean, this is probably in the standard library or something. I haven't really done a code audit of how it looks, but it's a nice tool to have. And it's horribly slow, of course, because it's pure Python, but it doesn't matter for what we do. And this is the whole code, that you create a signature for a ballot by passing in a ballot, which is just a bunch of text, which has anything. It has votes on it, but it just has anything. And then there's the private key that the web server knows and nobody else knows. But of course, the private key is associated with the public key that's published for everybody. Actually, I wonder, does everybody in the room understand the concept of public key cryptography? Is it worth saying a word or two about that? Does anybody want me to say a word? I sort of see maybe. Anyway, it's magic. The magic idea of public key cryptography is that you generate a pair of keys when you want to encrypt something. You don't use one key. And these pair of keys have this mathematically intractable connection between them. But they have this property where if you encrypt something with one of the two, then you can decrypt it with the other one, and which also lets you sign the same way. You can sign something with one and then verify it with the other. And so it creates a system where I can tell the whole world my public key. I mean, actually, if you come up to me afterwards, I use GPG, which is derived from PGP, which is a public key cryptography system, and I will give you a business card and it has my GPG key on it, the thumbprint of it. And so it's a fairly widely used thing, and it's such a wonderfully elegant system. It's called RSA after a bunch of smart guys named Ravish, Shamir, and Altman. Is it Altman? Whatever. Who invented this? It's based on large primes and factorization and things like that. But anyways, the idea is that the web server that does the election has this private key, publishes a public key, and when they generate a signature, they use the private key to sign, and everybody can verify that that private key and nothing else was used to sign this ballot, which is a much stronger commitment by the election administrator or the machine, which is actually acting as the election administrator, than we got by just publishing ballot IDs. And in particular, the system is nice that it allows you to verify that signature right when you've created a ballot. So this ballot that you can't see very well looks like this, and I don't know if you can see it at all, but there's a button at the bottom that says ballot verification code. And if you click on that, you get some actual Python code, which is the code that verifies that your ballot was signed by the election administrator, which is the machine. And it really is authenticated. But not just authenticated. It's the election administrator has committed to it. They have no way of changing that. And if they try to deny that ballot later on, they can't deny it because the public key is published, and it prevents deniability of that ballot. So they can't remove it without being caught doing it. And I have to do it on 2 pages, and I simplify the code just very slightly that's actually on the web server. But it's actually very simple. So you download this code just by clicking on that link, and this is what a ballot looks like. The way Massimo did it, the ballot is the actual HTML, and the actual HTML is a little more complicated than that, but it could just be a text file or whatever. It's text that makes up a ballot. And you can see that I voted, I've checked off yes, but I've not checked off no and abstain for this vote, and it has the ballot ID as part of it. And then there's this signature, which is the thing we saw before in the little tiny type, and I haven't displayed it all on screen, but those are part of the digits of it. And then there's this public key, which we publish to the world, and that is actually the whole public key, and it's, a bunch of letters that are probably too small to read as well. And then the entire validation of your ballot is these 4 lines of code that you see. You just get the public key using this method from the RSA module, and you call the verify method with the public key and the ballot and the signature, and it tells you that your ballot is valid or invalid, and it matches the private key public key pair that's associated with that election. So that is a real commitment to that ballot being part of the eventual tabulation of that election. Well, that's pretty much what I say on this next slide. Of course, after you see that screen I said, you can save it, you can save the HTML, you can save the signature, you can save the code that I just showed you, so that if the election administrator, the web server, or whatever, denies having received that ballot later, you can say, oh, no, I have this thing, and it's signed, and it's provable. So this is the guarantee that I talked about near the beginning, where I think it's really interesting and profound that the election administrator, or the web application that does it, itself is prevented from tampering. I've, as either I, the code, or I, the person, have tied my own hands in advance, and I can't falsify this election if I want to. Let's get water. Well, I did mention on the slide, this is a nice advantage of doing it on the web this way. Since you need to generate the signature of the actual cast ballot, not of the blank ballot with the ballot ID, that's sort of a real-time thing, and it sort of has to happen in an interactive way, which really doesn't make sense in an email model. It makes sense in a web model or some other sort of interactive thing. I mean, I suppose it could be an app on a mobile phone, too. You can do it that way or something, too. But it has this sort of instantaneous and interactive quality to it. Well, safer. Like before, after you've done the selection on this web interface, you publish all the ballots, and everybody can tabulate them themselves, and everyone can verify them themselves, and they can look at their ballot IDs that were included. There's a slight variation at the end of it. The people who were eligible to vote and received their UUID but then decided not to vote for whatever reason, we go ahead and generate blank ballots for all of them and send them a confirmation email that said, you haven't cast a ballot, but here's the ID of your blank ballot. So it's sort of as if they've cast a ballot, but they've cast a special one that doesn't have actual votes on it. It just has the word blank or something. But that does the same effect that we described before, where it rounds out that every ballot ID that could have been cast is verified as having been involved in it. And since it's a technical talk, I need to have a picture of a cat in it, and this is my kitten back home, and she hasn't quite yet pushed up to Cobra pose. I think that this is called Python pose. And that's the stuff I've talked about, so I'd love to answer questions or just chat about either the first or second part of this talk or anything else. Yeah, sorry. Questions or any comments? I'd love to hear them.
If you have any questions for David on the voting system or otherwise on PSF, we can go ahead and ask. We have like 20 minutes till the next talk starts. Hello? Hello? Hello?
Hello.
Hello?
Hello. Hello. Yeah. So I have this question about the voting system. Yeah. Hi. So the system you described actually like. So my question is about the voting system. My question is about the voting system.
Yes.
Yeah. So in the system, actually, each person who is voting actually sends the vote. Can in the process of the vote itself be anonymized? As in, like, there's no like, can we protect the vote by some cryptographic hash or something? Hello.
Well, in the system that was already used in prior PSF elections, there's just the anonymization at the beginning, and the thing that's sent to the voter doesn't have any sort of hash or anything involved in it. Which I'm not really sure where you would put something like a cryptographic hash in that process. But in the web version of it, the unique UUID sort of serves that role. That is customized to that voter. I'm not sure. I may be missing something you're asking.
What I meant was like. Yeah. So what I meant was that can we generate a count, from the like collective hash of all the users basically, rather than counting the votes basically. In this system, though, I can still find out who voted for what. Like.
I think enough people are leaving. The mic doesn't seem to be working. Why don't you just come talk to me afterwards for privately? I apologize, but it seems to be audio difficulty.